Okay, another aspect of our numbers, which is really, really important, is the ability to calculate factors. So hopefully we should recognize or should be familiar with this idea that a factor is a number or a term or something that divides in evenly to something else. So if I have one thing like a number, let's say 20, then a factor of 20 would be a number that divides into 20 evenly, leaving no remainder. So you're thinking like 2 or 5 or 10, something that divides in to leave no remainder. And factors typically come in pairs. So we'll have one factor that divides in and gives us another result. So say for 20 there, if I divide 20 by 2, I get 10. So 2 and 10 would be considered a factor pair because both then multiply to bring me back to that 20 that I started with. So when we're listing factors, it can be helpful to just get into the habit of listing the pairs together. And I suppose this is going to help us in later situations when we're working with factors, even kind of future questions when we get into kind of algebra and things like that as well. So it's good to get into the habit now. The other thing with factors is, like with lowest common multiple, there is a kind of ideal or a goal or a kind of common factor that we can look for, and this time we look for the highest common factor. And I suppose the reason we look for the highest one here is partly since it's a limited number, like every number has kind of a limited number of factors, we are able to get a highest factor. And then also that can be useful for us in certain calculations to kind of know what is the largest number that does divide into both of these numbers. So that can actually be kind of helpful for us to be aware of. So let's look at listing the factors and we can see what I mean when I'm saying that we kind of list them together. So if I start with 12 here, I list this in what we call a factor tree. And I would usually start with 1, and the number that corresponds with that, if I divide 1 in, it does divide in evenly and it gives me 12. Then I would try 2. Does 2 divide in evenly? It does, and it gives me 6. Then I would usually go 3. Does 3 divide in evenly? And it gives me 4. And by listing them out this way, I've come to a point where I have 3, and the next number I would try would be 4, but I've already accounted for 4. It's already written on the other side. So I actually don't need to do any more. I've covered them all. So the 6 factors we have here are 1, 2, 3, 4, 6, and 12. Let's do the same for 32. So we have again 1 and 32. Does 2 divide in? It does. It goes in 16 times. Does 3 divide in? It does not. Does 4 divide in? 4 does divide in. It goes in 8 times. Does 5? No. Does 6? No. Does 7? No. Does 8? It does, and we've already accounted for it. So we again only really have 6 factors there, but some slightly bigger ones than we had with 12. If I want a highest common factor, then I need a number that divides into both of them, and I want the largest such number. So here the largest one of those, the highest common factor, is 4. Another common factor would be 2, and another would be 1. And obviously 1 will always be a common factor no matter what numbers we look at. Let's do another question like this one. So again, listing out the factors of 18, 1 and 18, 2 and 9, 3 and 6. Let's look at the factors of 27. Factors of 27, 1 and 27, 2 doesn't go in, 3 and 9, 4 doesn't, 5 doesn't, 6 doesn't, 7, 8. So we're just left there with 9. And then 36, same again, 1 and 36, 2 and 18, 3 and 12, 4 and 9, 5 doesn't, and 6 does with itself. So 6 there is kind of the common, it's kind of a shared factor, I suppose. 6 divides in to leave 6. It's kind of an unusual factor pair where there actually is just a repeated number. So now we're looking for a common factor that is shared between these numbers, and we want the highest of those common factors. So as we've said, 1 is always a common factor. Another common factor there for all 3 would be 3. And the highest common factor they all share is actually going to be 9. The largest number that divides into all is actually 9. So being able to, I suppose, list out the factors in that way in your factor trees is really helpful. And then just picking out the largest of them, I suppose, is the way that we're going to get that highest common factor. Similar then to the multiples, we might look at some word questions that actually make use of highest common factor. So here Alice has a certain number of beads. She has 24 red beads and 36 blue beads. She wants to make identical necklaces with the same number of red and blue beads in each necklace. What is the greatest number of necklaces she can make? So what we're being asked here is, can we divide these beads in some way to create the largest number of necklaces using all the beads up as best we can? So let's have a look. So we're going to look for a highest common factor. Let's do 24 first. We obviously have 1 and 24, 2 and 12, 3 and 8, 4 and 6. Let's look at 36. We have 1 and 36, 2 and 18, 3 and 12, 4 and 9, and we've said 6 and 6. The largest number that they both, or that divides into both of them, is 12. So the idea here is, if we're going to use up all the beads, then what we could do is we could make 12 full necklaces and have no beads left over. And that would actually mean us having 2 red and 3 blue beads in each. And that would be a way that we could use up all the beads that we have. We look at one more example like that. A PE teacher has 72 cones and 90 bibs. She wants to divide them into the largest possible number of identical sets. So dividing them into the largest number. So we're looking at highest common factor, or even greatest common divisor, we might sometimes see. With no equipment left over, how many sets can she make and how many cones and bibs will be in each set? So let's look at the two here. We'll start with 72. Well, obviously we have 1 and 72. We have 2 and 36. We have 3 and 24. 4 and 18. 6 and 12. 7 doesn't go in. 8 and 9. So I'm kind of content that I got them all now. Let's look at 90. 1 and 90. 2 and 45, 3 and 30, 4, and no, 4 doesn't, 5 doesn't, oh, 5 does, 5 and 18, 6, 15, 7 doesn't, 8 doesn't, 9 and 10. So again, we're looking for the largest number that divides into both of them, the largest number that divides into both of them. So there, that seems to be 18. So we can make 18 sets with 3 cones and 5 bibs. So hopefully we're even noticing there that even to answer the other part, dividing each of them by 18, I'm actually just looking at the other half. I'm actually, sorry, I've looked at the wrong one there. That actually should be 4. 4 cones and 5 bibs in each. So I'm looking at the other half of that factor pair there to work out how many of each is going to be in each set. So really here, it's all just about listing them out kind of in a systematic way so that we're able to identify each of them and then picking out the largest one as our highest common factor there.